Here we are at our example 1 from our 3.5 set of notes. We're asked to write an exponential function whose graph passes through the following pairs of points. So if for a moment we imagine that these 2 points right here, 1, 6 and 2, 18, are on top of this exponential function, in other words, they're part of this exponential function, then we know that we're assuming, because it's an exponential function, that it's going to follow this form y equals a times the base raised to the x power. And sometimes we've seen from class that we throw this b in parentheses. This is the same thing without or with. Now, looking at our 2 points, we'll just label this one as our x and y. Because again, any coordinate point has an x and a y. Likewise, this other one will also be, 218, will also be some x and y. Now, how we're going to treat these are actually kind of separately at first, with this point in the blue and then eventually this point in the red. Now, if we know an x and a y, well, what we can go ahead and do is plug in our x and our y into our exponential function. So just focusing on the blue one for right now. Again, that point 1 comma 6. Let's go ahead and plug in 6 for y. We have no idea what a is, so it is still right now a. Likewise, we have no idea what b is, so it is still b. But luckily, we do know the x value. It is, in this case, 1. Now, right now, we can't really answer too much more. We can kind of simplify this a little bit further, but we just pretty much still have 6 is equal to a times b raised to the first power. Well, that's still just b. But again, we have 2 unknowns, a and b, so that way we can't unfortunately just solve for a single variable. Now, looking at the red one, well, let's basically apply what we did with the blue one, but just with our point 2 comma 18. We know the y value, it is 18, so we're just going to go ahead and plug that in for it. Is equal to, again, no idea what the a value is, so it's still currently a. Likewise, we don't know what our b value is, so it's still currently b. But luckily, we do know the x value. In this particular case, with this point 218, our x value is 2. Just kind of cleaning things up a little bit, we end up with 18 then is equal to our a times b squared. Now, we're kind of still in a position where we still have 2 unknowns. However, taking a trip down memory lane, we do see that we have a system of 2 equations. This one right here, as well as this one right here. And so our end game then is to solve using either the substitution or elimination method back from last semester. Now, looking at this one, it's probably easier to do the substitution method. So let's go ahead and solve for a variable right here. Let's go ahead and solve for, let's say, a. So when we solve for a right here, we know that we would have to divide both sides by b. Because on the left side, on the right side, it ends up canceling out, leaving us with just our variable a equals 6 divided by b. Next, what we would go ahead and do is just substitute. We're going to substitute this value in to our other equation for a. Because keep in mind, we found out in the blue equation that a is equal to 6 divided by b. Using systems of equations with the substitution method, we can go ahead and substitute this part in for a instead. And when we do that, we end up then with 18 is equal to, instead of a, it's no longer a, it's this 6 divided by b, times our b squared. Well, now what we can do is go ahead and simplify our b's up. So we still have 18 over here equals 6 on top. If you wanted to, you could multiply the 6 times the b squared. If that's a visual little bit easier for you, then go ahead and do that. Now that we have one on top and one on bottom, it's just pretty much going to cancel out. leaving us with just 18 equals 6b. There's still a b there, just one of the ones got canceled out with a squared. So there's still a b there though. And then lastly, if we want to solve for b, we would just divide by 6 on both sides. Then b comes out to be 3. Now that we've found out what b is, our life is much easier in determining what is our a value. You can plug it into this one or the blue one. It's really up to you. Just looking at our two equations, I'll probably stick with the blue one. Anything raised to the first power is kind of nice and easy, so we'll go ahead and throw it in there. So when we do that, we end up with 6 equals, no clue what our a value is yet. We'll find them out in a second, but times our b value. So instead of b, we're going to throw in our 3 that we now know, raised to the first power. So then it looks like 6 is equal to a. 3 raised to the first power is still just 3. That's being multiplied by the a. And then lastly, we would just divide both sides. So it looks like a comes out to then be 2. So lastly, just to write an expression, write an equation, now with our a and our b that we just found, we would end up with y equals our a, which we now know is 2, times our b, which we now know is 3, raised then to the x power. This right here would be our exponential function that would work for both of these points. Again, that is example 1 from our 3.5 set of notes. This could have done a couple of other ways. Like, for example, you could have solved for a or b in this red one, but I felt like using the blue one might have been a little bit easier. So just use whichever one you feel is going to be easier on you in the end.